Hi, my name is Manish Gupta, and in this video, I'm going to talk about LaMini-LM, which is basically about training a diverse herd of distilled models from large-scale instructions. So let's get started and understand what is LaMini-LM and how is the instruction set for training LaMini-LM models generated. Okay. So the whole recipe is succinctly described in this picture. So the author sort of start by taking a few seed instructions, passing them to GPT 3.5, and then generating some synthetic instructions. These synthetic instructions are added along with existing instructions to again use GPT 3.5 so as to essentially generate synthetic responses. So that is how basically they generate Lamini instruction dataset. As you see here, for diversity, they actually also add topics from Wikipedia so that they generate diverse instruction set and therefore get really good responses, right? So now this Lamini instruction dataset is basically then used to instruction tune a bunch of models, and that is why a herd of models in that sense is leading to LaMini-LM variants of those models. Okay. So now a little bit about their instruction set. It's basically 2.58 million diverse instructions. So they start with an existing instruction set comprising 4 different sources: self-instruct, P3, Flan, and Alpaca. And then they do two things so as to expand on this instruction set. The first thing is example guided instruction generation with GPT 3.5 Turbo, and they do 3-shot. So essentially, they take 3 different examples, seed instructions, and then they basically ask GPT 3.5 to come up with more such synthetic instructions. Okay. The other thing that they do is to do topic guided instruction generation to enhance instruction diversity. So as I mentioned, they actually take 3,500 Wikipedia topics, those which are very popular, and of course those which are somewhat shorter, so that you can actually have many subcategories and so on. And then they use them so as to guide the instruction generation from GPT 3.5. Well, they use GPT 3.5 Turbo to generate these instructions as well as for the response generation. Now, if you think about it, this 2.58 million data set is 50 times larger compared to the Alpaca set itself. Okay. Now, using this, they basically train a variety of models as you see them here. So all of these are Lamini models that have been trained using this Lamini instruction dataset, 61 million to 7 billion in size. So the smallest ones, like the T5 one, is the 61 million parameter in size, while Llama 7 billion is, of course, 7 billion in size. They train 4 different families, T5, GPT, Llama, and Cerebras. Right? So some of these models are encoder-decoder models, while many of them are decoder-only models. So that's basically that, and that is how they come up with the Lamini variant of essentially these different pre-trained models. Okay. Now, how do these Lamini-LM models perform? So they perform zero-shot evaluation on 15 different NLP tasks covering question answering, sentiment analysis, paraphrase identification, natural language inferencing, co-reference resolution, word sense disambiguation, and the sentence completion. And here are the results. So if you look at these results, on the x-axis, there is the number of parameters, and on the y-axis, there is average performance across these 15 different NLP tasks. You see various kinds of curves here. The one with the pentagon, the red one, is basically the Llama Neo models. So that's basically the Llama Neo models curve. Then the orange one is Lamini Cerebras models. The blue one is basically Lamini T5 models. The red one is Lamini Flan T5 models. There are 3 horizontal curves that you see, the horizontal line. So this is Lamini Llama 7 billion, this is Alpaca 7 billion, and this is Llama 7 billion, right? So as you see, several models are actually better than Llama 7 billion, right? So remember, Llama 7 billion is the original Llama 7 billion, not Lamini fine-tuned one, right? Or Lamini instruction-tuned one. But if you so therefore, the takeaway is that some of these Lamini-LM models are actually better than Llama 7 billion and also Alpaca 7 billion. So for example, if you look at this guy, this green guy, which is effectively Lamini GPT, actually it's better than Alpaca 7 billion also. Similarly, if you look at these 2 red guys, they're actually better than, they are Lamini Flan T5 models, and they're better than Llama 7 billion parameter models. Okay. So effectively saying Lamini Flan T5, 248 million parameter model, is actually better than Llama 7 billion, or equivalent at least, compared to Llama 7 billion parameter model. Broadly, what is observed is that the encoder-decoder Lamini-LM models are better than decoder-only Lamini-LM models. Right? So they also did human evaluation on 114 instructions, and they asked humans to rate whether the responses which are generated are of type A, B, C, or D. A meaning valid, acceptable, and accurate responses, B meaning minor errors in the responses, C means significant errors in the responses, and D means invalid and unacceptable responses. And here are the results. So what you observe is that if you look at GPT-2, right, GPT-2 model, the crazy number of unacceptable responses. Similarly, if you look at GPT 3.5 Turbo, most of the responses are of type A, which is basically, very good responses. And what you observe is that Llama 7 billion parameter model is not too bad. Of course, there's a large gap to be filled in, but it is actually better compared to, let's say, Llama 7 billion, which is way worse on this human evaluation complex. It's a very complicated, it's a very difficult to answer data set of these 114 instructions. Yeah. Now, from a toxicity perspective, they do an evaluation to evaluate how toxic are the responses generated by these models, and they experiment with real toxicity prompts. And they observe that broadly, when you do the Lamini fine-tuning, it basically increases the toxicity of small models. So if you notice, the Flan T5 models, actually, if you do the fine-tuning, the toxicity is actually increasing, unfortunately, right? I mean, here it stays almost the same. But if you look at the decoder-only models like GPT and Llama 7 billion, actually the toxicity reduces, right? So toxicity is reducing, which is a good sign in that sense. Okay. Okay, so lastly, how much do LaMini-LM models hallucinate? So to do good hallucination evaluation, they actually propose this set of 40 different questions. So 10 of these questions are about things that never happened. So what year did the dinosaurs go extinct for the second time? Well, that never happened in that sense, right? Similarly, 10 of those are far future events. So for example, what is the GDP of China in 2090? Well, who knows, right? And then, 10 of them are nonsensical questions. How many legs does a fish have in that sense, right? And the remaining 10 are very obscure questions. So who is the 42nd most cited person in NLP according to Google Scholar in 2020? Now, pretty difficult to answer in that sense, right? So, and what they observe is that alpaca 7 billion, if you look at that model, which is fine-tuned using alpaca 7 billion, well, it basically makes a whole bunch of hallucinations. Similarly, GPT 3.5 Turbo is really awesome, does not hallucinate. In fact, only in one case it hallucinates, but most cases it does not hallucinate. And lastly, if you basically look at LaMini-Llama 7 billion parameter model, that's the best one, hallucinating the least compared to the other Lamini variant. So, Flying T5 is small and therefore nice, but well, hallucinates a lot. 36 different hallucinations compared to 12 with Llama 7 billion parameter. Okay, so in summary, in this video, I talked about Lamini instruction dataset, which basically is a 2.58 million examples dataset created mainly by prompting GPT 3.5 Turbo. Then we talked about various Lamini models, which are obtained using knowledge distillation from GPT 3.5 Turbo instructions and responses dataset, 6 encoder-decoder models, and 11 decoder-only models, ranging in size from 61 million to 7 billion parameters. It has been evaluated on 15 different NLP tasks, and they observed that yes, Lamini-based instruction tuning gives a significant boost in performance, in average performance. They also evaluated on human evaluation and found that there's a large gap to fill compared to GPT 3.5 Turbo, but well, I mean, it's still reasonably good. Hallucination wise, yes, there is again quite some hallucination, and they actually did, contributed a hallucination data set of about 40 examples, which is a pretty interesting way of evaluating hallucination. And lastly, they also did a toxicity evaluation of their models. Okay. So that's it for this video. Thank you for watching. Hope you liked it. Connect with me on my LinkedIn or look at my search on my homepage. Thank you.